Dear students, good morning, namaste. Again, I come to in front of you to take the fourth division, that is the fourth chapter, vector algebra. Successfully, we completed 3 chapters, trigonometric inverse functions and matrices, determinants. This is the fourth one, vector algebra. The vector algebra is a main branch of mathematics, but it is from the physics only. The mathematics are telling that it is a physics concept. Of course, the only definition is from that it starts by definition. That is physics, from physics. The physical quantity. You know it well. In the physics, you might read that one and dealt with that concepts, vectors, scalars. Yeah, okay. But it's very simple, very basic. That definition is there. But mathematically, a big a chapter is formed. So many concepts are there. Actually, by using the mathematical application, with the help of mathematical application, we can develop the vectors. Okay, now, of course, basically its concept is physics. From physics, it is formed. But we are using our mathematical applications. So many concepts are there. Through that one, it can be developed in such a way. In some reason, you see, at some stage, the vector algebra and the geometry, 3-dimensional geometry, not 2-dimensional geometry. 3-dimensional geometry is a different one. Length, breadth, height. 2-dimensional means our blackboard is 2-dimensional. Only length and breadth is there. But for example, you see this one. It will not be on that board itself. Okay now? Okay now? Because it is containing length, breadth, height. This is 3-dimensional. Myself is 3-dimensional. Everything in our society, the world, everything is a 3-dimensional only. Okay now? This geometry is a different one. But in order to know, to identify, we can draw the pictures on the 2-dimensional one. Already in the geometry, we dealt with the 2-dimensional geometry, x-axis, y-axis. In the 3-dimensional geometry, some z-axis is there. X-axis, y-axis and z-axis is there. Okay, okay, that is a different one. But the vectors, the concept of vectors is everything in 3-dimensional only, not in 2-dimensional. After completion of our vectors, we will go to discuss about the 3-dimensional geometry. That is okay, leave it out. Now, the vectors, the vector algebra, it is come under algebra part. Sets and relations, functions, matrices, determinants, probability, series and sequences, so many units are there. These are all come under the algebra. Here vector also is one of the units of algebra, main branch. Okay now? Yeah. Now, you see, before going to start the vector algebra, it is a needed basic concepts. What are the basic concepts? Already you know it well. Scalar and vector. Scalar is a physical quantity. Okay now? This is a definition important. A physical quantity which contains the magnitude only is called, magnitude is only, is called the scalar. And commonly, generally, it is denoted by small letters. That is A, B, C, L, M, N, P, Q, like that. That is the scalar. For example, What is the length of a table? What is the height of your building? What is the area that you contain in our field, that is in the farm? What is the area? What is the volume of this box? Like that. These are all some concepts, some quantities, a physical quantities. Is it not? What is the length of your arm? What is height of about you? What is your height? What is the height of the building? What is the area in your hall? What is the volume of air in your front hall? Like that, all these are all, of course, it is a physics. These physical quantities, it is containing only the magnitude. Okay, na? Only that magnitude is contained. Length, 10 units length. My height is 6 feet. The height of the building is 30 feet. The area of my house is 1200 square feet. The volume in my room is 1000 square feet. Like that, we may tell. All these concepts, all these quantities are having only some magnitude. 10 meters, 30 feet, like that only. All these physical quantities having only the magnitude. Such type of are called as scalars. Okay, very simple. You know it well. It is not needed. Discussing about this one, it's a waste of time. Scalar, you know it. Length, breadth, area, volume, distance. Distance also known. Suppose, what is the distance between 2 points, A and B, P and Q? That is, okay now. So, distance, length, breadth, width, area, volume, height, all these are all scalars. Okay now. Usually they are denoted by small letters, small a, small b, l, m, n, like that. Now, I am going to discuss about the vector. Here it starts, vector. Vector is also a physical quantity. It is also a physical quantity that contains magnitude. That contains magnitude as well as the direction also. It is very important. A physical quantity contains magnitude as well as direction. In the vector, there are two concepts are there. One is magnitude, another one is direction. It is called a vector and is generally denoted by capital letters. Capital letters. Of course, here I wrote a V bar, C D bar, P Q bar, L M bar, like that. O A bar, O B bar, O C bar, just like. Two letters are there. Of course, the vectors in some books also it is denoted like that. A bar, B bar, C bar, D bar, P Q bar. But you avoid these notations. You always prefer to write as a B bar, C D bar, P Q bar, like that. Okay now? This is a definition for a vector. Vector is a physical quantity containing magnitude as well as a direction is there. I will clarify it. The geometrical interpretation. Geometrically, we can discuss, we can define the vector. Suppose a particle moves from a point A and it stops its motion at the point B. It starts its motion from A and after some time it reaches the point B. It starts from A and reaches B. That is the meaning. Okay, na? A particle, a thing, or a body, or a car, whatever it may be, moves from A, the point A, and stops its motion at B point. At B point. Starts at A, ends at B. Then, such that, it is also important, such that it covers a distance. This is important. It covers a distance. It covers a distance, a units. Then, this physical concept, this verbal concept can be expressed by a vector everywhere. Here is important. This expressed by a vector everywhere. You see, A, B, here A, B, bar. Arrow mark is there. Okay, now it is A to B. Okay, now everywhere. Where A is a initial point and B is a terminal point. Initial, terminal. And the direction is from A to B. Direction is from A to B. Okay, now? And the magnitude is small a, which is the length, which is the distance that covers this one. Geometrically, this is. A particle starts from A and reaches after some time reaches the point B. Here, it covers a distance small a. This is the length, this is the magnitude of this vector. And from A to B, so this is the direction. So, here two concepts are there. Two measurements are there. Two parameters are there. That is, one is the length and one is the direction. This is important. From A to B. From A starts, ends at B. So, direction is there. Not A to C, not A to D. A to B only. So, that is important. That concept is also contained in this physical quantity. So, this is called as a vector. Okay, here this is mentioned by vector AB bar is small a bar also. The length is in some books and sometimes we may mention a small letter with with bar. Here you see this is only bar. If a single letter, small letter is there, of course it is also vector. L bar, M bar, N bar, yeah, R, AB bar, R, BC bar, PQ bar, LM bar. If you mentioned the capital letters, then it is arrow mark from A to B. Very clear, from A, B. Initial, terminal points are there. So arrow mark must be there. This is notation. If a small letter with bar is there, also vector. It is notation only. In a different way, we are mentioning it. We are denoting it. A bar, small b bar. Suppose a vector is there. It is P and Q. It covers a distance. Suppose L. Here this is a PQ bar. It is a L bar. You see, you find the difference. When you use the vector by two letters, initial and terminal, then arrow mark is needed. Of course, in some books also, PQ bar simply is given. Of course, but actually this is the correct notation. Okay, now L is it's a distance, a small letter. L bar. Of course, some books L bar also it is given that arrow mark. Not needed. You maintain like this only then. Okay, now is it clear? Okay, now yeah, that is the definition of vector. Yeah. Okay. Now we discuss about the types of vectors. Types of vectors. First we learn the basic concepts of scalar, vector, and geometrical interpretation is okay. Now we are going to discuss about the types of vectors. Types of vectors is important. You see that? Equal vectors. Equal vectors. Two or more, not only two, 3 vectors, 4 vectors, 5 vectors, 10 vectors, n vectors. 2 or more vectors are said to be called equal vector. are said to be called as the equal vectors if they have the same magnitude and the same direction. Both magnitude and direction must be same. Vector means magnitude, direction. Two concepts are there. That two parameters, that two concepts must be same. Suppose it is AB bar, say 10 units length, and another one, same direction, it is a CD bar, it is also 10 units. Then AB bar is equal to CD bar. Just the position of the vectors are in a different way. Now, you ask me, here onwards I want to tell. Vector means it is a three-dimensional geometry. I already told. You see, you are assuming this corner is, you assume this is this one, add it to it. Okay now? It is a, or otherwise, you take this is a corner horizon and it is x-axis, it is y-axis, and you assume this is a z-axis. You assume just like. Okay now? It is x-axis, y-axis, and it is this axis. In this one, I am here. Now I am not on the board. If I am on the board, it is a two-dimension. I am in a room. You just assume that this room is, this is x-axis and y-axis, and we assume this is a z-axis. Here is any particle, anything is in a three-dimensional. Here you see, a V bar is like this. My arm is just like you assume. This is A and this is B. It is a B bar. Vectors are always in the space only. Of course, for the clarity, we are writing on the board. It is not two-dimensional. It is three-dimensional. It is a B bar. Some length 10 units. To a B bar, that line AB, another a line CD bar. It is parallel. The direction is same. The line of directions are parallel. Okay na? A to B, C to D, P to R, L to M, like this. All the lengths are the same. 10 units. Like this. Another vector, you take it here. It is also parallel to this one. Will agree? Suppose here, it is also parallel. Say it is a PQ bar. It is also 10 units. It is LM bar. Now, a V bar is equal to PQ bar is equal to LM bar. Okay, na? Is it okay? Na? In our room, you assume. In your room, you assume. On the board, on the wall, this is x-axis, it is y-axis, and it is a z-axis. That corner is horizon. Here, three lines are there. AB, length 10 units. CD, length the same length 10 units. LM, here also PQ, here also RS, like that. But all the lines are parallel. Okay now? Otherwise the direction will be changed. Suppose AB for PQ, they are parallel. Suppose like this, it is RS. Will you agree? Is it parallel to PQ? Is it parallel to LM? Is it parallel to AB or CD? No. So direction is a different one. It will not equal to AB bar, those vectors. Thus, equal vectors means the magnitude and direction must be same. Okay, na? It is very easy. Now, we'll come to parallel vectors, second one. Two or more vectors, here also, two or more vectors are said to be called parallel vectors. If their lines of direction are defining in such a way, their lines of direction, here it is important, lines. their lines of directions are parallel, and whatever, here is important, and whatever their magnitude may be. You see, it is a V bar. The geometrical interpretation I am taking here on. A V bar is 10 units length, yeah, from A to B. It is a vector, a V bar, yeah, okay. And a CD bar is a vector, it's a direction. The lines of directions are same, but the magnitudes are different. So it is 15 units. Then it's a different one. Is it that? Yeah. Suppose another vector is there. The lines are same, parallel, but it is a PQ bar like this. Direction is different. The PQ bar, it is reversed. It is in opposite way. Okay, even though the lines of directions, they are parallel, but the direction are different. A to B, but it is P to Q. It is a different, opposite directions. Even though these vectors are called as a parallel vectors. Okay, Rana? You see definition. Two or more vectors are said to be called as a parallel vectors if their lines of directions are parallel. Parallel means may be opposite and the same direction. You try to catch it. And whatever the magnitude, one is 10 units, another one is 15 units, it may be 8 units. What it may? The lines of directions are parallel. That is why they are called as a parallel vectors. Okay, now magnitudes are different, may be equal. If magnitudes are also equal, then they are called as equilators. But it is not compulsory. Okay, now that is parallel vectors. Next, collinear vectors. Two or more vectors are said to be called collinear vectors. Collinear. In the name itself, the meaning is collinear. Collinear vectors, if they lie on the same line, whatever it may be the magnitude. You see, it is a V bar. Okay, now it is C and D is there. Of course, a V bar is a vector. CD bar is also a vector lying on the same line. AC bar is a vector lying on the same line. DB bar is also a vector lying on the same line. Suppose the total AB bar is some 20 units. Its length is 20 units, magnitude. AB bar is 5 units, you assume. AB bar is collinear with CD bar because they are lying at the same. This AB bar, CD bar is lying on the AB bar. The line is there. It is lying on the same vector. All the vectors are lying on the same line. There are so many vectors are there. AC bar. AC bar is some 6 you assume. And CD bar is 9 you assume. I mean not CD, DB bar. 9 units. Okay now. This is 11 plus 9, 10 units. Okay now. AC bar is a vector. CD bar is a vector. DB bar is a vector. CB bar is also a vector. AB bar is a vector. All the vectors are lying on the same line. Then whatever it may be the magnitudes, that is also there. It is not needed to having the same, different types of magnitudes. But they are lying on the same line. Not only this one, another concept is also there in this one. Suppose, be careful. It is A, B, C is there. It is not midpoint. A C bar is a vector. BC bar is another vector. Say it is 10 units, say it is 8 units. The two vectors are lying on the same line, but they are opposite. They are opposite. Is it not it? A to C, B to C. They are in opposite side. Even though here AC bar and BC bar, not CB bar, BC bar, R bar BC in the reverse. AC bar, BC bar are lying on the same line. So here also the vectors are called as a collinear vector. Here AC bar, CD bar, DB bar, AB bar are lying on the same line. So it is called as a collinear vectors. Like this, we have to learn it. Okay, Rana? Yeah.